Awesome. Good morning, Stockholm. Woo. Yeah! I didn't know what kind of crowd I was going to get. I love it. A little bit of energy. We're up. So today, I'm going to do a little talk about building APIs at the edge. Anybody working with edge technology in the room? Just a couple of hands. Okay, awesome. It's great. I get to hopefully give you some education. But first of all, whenever I do a talk, I think I really should take a selfie. And I always forget. But this time I put a slide in. So it is selfie time. So I need your most energetic hands up. We're going to have some fun together. Come on, look lively. Here we go, selfie time. Love it. What a great crowd. Okay, enough posturing. Let's do a little bit of shameless plugging quickly. First of all, I'm Josh Twist. I am the co-founder and CEO of a company called Zuplo. Before that, I used to work at Microsoft a while back, and I actually founded several products in Azure. If anyone using Azure here? Logic Apps, keep your hands up. Sorry, that's one of mine. Power Automate Pro, anybody? Yeah, okay, not great. Azure API Management. Oh, that's one of mine as well. I actually founded that product in 2013 with the acquisition of a company called Epiphany. After that, I was at Facebook for a while, and then I was head of product at Stripe running the payment methods team, looking after something like 30 APIs, and then decided I was done with the quality of API management products today, including Azure, sorry. And so founded my own thing called Zuplo with my co-founder also from Microsoft. We do a bunch of things. We just launched a new channel called API Excellence on Zuplo, so subscribe to that. You'll find lots of content like this here. And then we have, obviously, Zuplo itself. I'm not going to talk much about that, don't worry. It's an API gateway designed very much for engineers. We have lots of hosting options. One of them is running at the edge, actually, which I'll be talking a lot about today. And the expertise that we have in that area come from building this product, natively powered by OpenAPI. And then we also have a ton of open source products you can all go and use for free. So things like Sudoku, which is our open source API documentation portal. We think API documentation should be free, so we give away ours for free. Obviously, if you use Zuplo, you get this included, but nobody buys Zuplo for the portal, so we just gave that away. We have a product to help you with your open APIs called Rate My Open API, and we have a thing called Mockbin that allows you to do quick mocking. Let's get talking about Edge, enough plugging. So what we're going to do in this chat is we're going to who codes in the room? Okay, so a good chunk of you. Good, because we're going to try and do some live demo. We're either going to demo some code, or we're going to demo conference Wi-Fi. One of those things is going to happen today. We'll find out. Okay, so we're going to talk about Edge. What is it? Why would you use it? What are the caveats? There's a bunch of challenges here. It's a complicated space with a lot of benefits, but there's definitely some reasons to avoid or some things to work around that we'll talk about today. Then we'll look a little bit at the architecture. It's pretty cool. It's pretty interesting. And some of the innovative things edge providers are coming up with to deal with some of these challenges and give you some new options. We'll try and do a live demo of that today, and then we'll wrap up with some best practices. So first of all, let's talk a little bit about the different edges, because it turns out when someone says edge, it might mean a bunch of things. I think there are three classifications of edge: pseudo edge, CDN edge, and device edge. I'm not going to be very kind about pseudo edge. I think it's kind of marketing, to be honest. So there are folks who call their products edge capable, but they just run in a few of the major data centers that are provided by the cloud providers. I don't think that's really the edge. You know, the edge means you're getting real close to the user. That's the whole point of the word edge, not just a bunch of things in the middle. So I don't think it's real. It's definitely better than just being in one data center, but it's not real edge. CDN edge, I think, is a much more real, more interesting thing. And so providers like Cloudflare, Akamai, Fastly, these folks have lots of data centers. You know, Cloudflare has about 300, I think. Akamai, 4,200. So they are literally everywhere. And if you're delivering compute for that, that means you're within milliseconds of your users. You can get you sort of insane performance gains. We're going to play with that a little bit today. And then there's the CDN edge is what I'm going to talk about today, by the way. It's a back-end compute. We're going to look at how you can build APIs that might run on the CDN edge. The device edge is another type of edge that I'm not going to talk about today. And that's where someone has compute running on a device that's very local, like maybe it's your mobile phone, or it's some IoT device in the room, or in some cases, Some folks, like restaurant chains, run Kubernetes clusters in every restaurant, like Chick-fil-A. That might be considered more device edge. I'm not really going to talk about that either. We're going to focus on the CDN edge with lots of data centers. So what does that really look like when I say lots of data centers? So this is it might be a little dated. I might be missing one here. Apologies. This is Google Cloud Platform's distribution of data centers. So lots of gaps in there. But if you deployed everything to all of those, which isn't easy, you got to replicate things and choose to go into all those different data centers, then you're getting some distribution. But compare that to just Cloudflare's, for example. You can barely see the map here, unfortunately, because of the contrast. Sorry about that. But you get the idea that they're everywhere. There's 300 of these things. You're basically within 50 milliseconds of every human on Earth if you're deploying to this map. So you want to be everywhere with Edge because you get incredible performance, also incredible high availability. If one of those things goes down, you'll be hot swapped over to another one. You won't even know. And the response time's still going to be great because the nearest one's just sort of one city away. So being everywhere all at once is really critical. One of the other cool things about these Edge technologies is the deployment model, and how it gets you through the anxiety of deciding where to deploy. Where do most of you folks deploy your cloud workloads? Is it gonna? I'm gonna say like EU West. Is it US East? Are you all going in US East as well? Just shout out some places, please. US West. You like people waiting for things here in Stockholm? What's going on with that? Well, we'll play with that later, actually. I have a demo where we're going to use some US West, so we'll see what that looks like compared to what it might look like if you were deploying on the edge. So I'm going to do a little demo of this, actually, but before you go and scan that QR code, because everyone's going to play along, and this is what I mean about a demo of conference Wi-Fi. We'll see how this goes. So what I did, I made a little web page, right, that's deployed. It's deployed to Vercel, which I kind of think of as a pseudo-edge platform, honestly. Sorry, Guillermo. And it's got a drop-down in it that you're going to pick. You're going to pick which data center you want to ping, and it'll show you the timing. So I've got one deployed in US East and one deployed actually in EU West, which is pretty close to it. Should be fast. And then a third one deployed to Edge. Now we're going to see a bit of randomness because it's conference Wi-Fi and the ping times are going to be nuts. But hopefully we'll see that the fastest is the Edge platform. But one of the other things I want to show you is just how slick deploying to Edge can be. So when you think of deploying to a traditional cloud platform, I think I'm going to put it in US East, and maybe I'll put another replica over here. One of the cool things about these Edge platforms is you just go everywhere. You don't have to choose. You're just in all of these data centers immediately. And I'm going to show you just how real that is. I'm going to actually change the back end for this test, for the Edge back end, is actually Zuplo, my product. We're going to change it live now. I'm going to prove it by finding a volunteer. Someone put their hand up. Quick. Oh, look how scared they all are because I'm looking at them. I'm just going to pick you. OK. Pick a fruit. Just pick a fruit. A strawberry. OK, so we're going to update this API now to mention that fruit, so you'll hopefully believe me that I'm telling the truth here. So here is my endpoint called ping. And I've got some custom code in this. And it says Josh to customize live. Hopefully you can see that. I'm going to say, hello, strawberry fields forever. And I'm going to click save. And conference Wi-Fi be with me. That should hopefully deploy. There you go. In 3.9 seconds, you can see down the bottom, we just deployed to 300 data centers around the world. Now, that's what Edge deployment could look like. It's kind of incredible for what it can do for your workflow. So I'm going to go back to the slides now, and you can all scan that QR code and start playing with the latency. And you should see, when you try the Edge version, that you get the message from I can't see your badge name. Ezra, who suggested we do strawberries. So try it out. Is it working? Are we having any joy here with the Wi-Fi network? You should find that US East is going to be about 130 milliseconds, I think I saw. These are very simple APIs that page is calling. And then EU West was about 60. And then Edge, was up and down depending on the network, was about 20 to 40, I was seeing. Are folks seeing that? Or is it making me look a fool? Thumbs up here. This guy's impressed. He's an Edge fan already. I can see it. Oh, choose the edge one in the drop-down. So you get to pick only the edge. I only updated the edge one. It's too slow to update the other ones. They're running on GCP. It would take me 20 minutes. What, sorry? Oh, geez, that's not good.
I have 42.
42. I mean, this is the conference Wi-Fi partly. But I'll leave this live. Play with it throughout the day. Play with it on a different network. I'm not going to take this thing down. And you should see that you're getting around 20 milliseconds-ish for edge. And that'll be wherever you are. That's one thing that's cool. When you fly home, the edge one's still going to be quick because it'll find the data center nearest to you. So makes a big difference. You know, there's been a lot of discussion. Companies like Vercel talk about the performance of compute. And the one thing that we fight against that's really hard is the speed of light. We just can't fix that, right? We're working on it, but the physics is just not there. We are bound by space and distance. Someone's got a question.
But it's actually interesting because if you're accessing via mobile, like cell network, it's not relevant anymore. You get the same response time. Via Wi-Fi, it makes a difference, but if people are really on the go, you will have edge.
So the comment here is that if you're on cell networks, it doesn't make a difference. I mean, let's chat about it later, but I don't think that's true. Maybe you're seeing it now, and that's just an observation of something here, but absolutely you should still be routed to the nearest data center amongst those three, or roughly the nearest data center amongst those 300 instead of the 24 or whatever. And typically you're only going to be deployed to 2 because it's too hard to deploy to all 26 GCP data centers. So that's a massive, massive difference. But yeah, let's chat later if you want to hold on to that. Okay, so everywhere, all at once, all of the time. So this is one of the key things, you know, you don't have this sort of decision anxiety here. It also means you just get instant high availability as a result of deploying to these platforms. You know, I'm already starting to design a very, very distributed system, just by the nature of deploying to this, that means HA just comes out of the box. And that's actually with Zuplo, our free product and our self-serve product is all running on Edge, and our customers get insane high availability just as a result of the fact we designed it to run on these platforms. Now, having said all that, there are limitations, as always. With any sort of great innovation and great advance, there comes some catches. So let's go through them one by one. So this technology is typically based on WASM. Are folks familiar with WASM? WebAssembly? It's a sort of secure runtime in which you can run a variety of types of code, or web workers. So the same technology that allows you to build service workers inside the browser. That means it's a pretty full programming environment, but it's not exactly the same as, say, running Node.js or, you know, running Python on just on sort of raw tin. There's no file system. There's a bunch of constraints. And that means there's some limited compatibility in terms of the libraries or package managers that you can use. Now, this is improving dramatically. There are a bunch of projects that are working on this. There's WASM itself. There is Cloudflare Workers with Workerd. They're moving towards full Node.js compatibility. There's another project by the founder of Node called Deno, if you're familiar with that, just got to 2.0. That's a very similar concept, very lightweight, secure runtime. We'll talk more about that in a minute. So one of the challenges with Edge is you are going to have to sort of rewrite a bunch of things to get on there. It's not just going to be able to lift and shift a workload you've got today and deploy it to, say, Cloudflare Workers, which we'll be demoing. And that's actually was a challenge for us at Zuplo. We knew we wanted to do Edge. I couldn't use Nginx or all the sort of core pieces that most API management products have to use. So we had to build ours from the ground up to run on this technology. Now, the nice thing is, that stuff is compatible, can be run on other hardware. So once you get down to that subset that runs on workers, that code base is very portable and can run on pretty much anything, which gives us a lot of options, which is nice. The other challenges with this is it's not really designed today for very sort of compute-heavy workloads. This is not a technology where you would run machine learning or mine crypto. Although things are coming in that space as well, but that's just not what it's really designed for. But it is great for sort of request-response stuff running as a web server, if you will. One of the other challenges that we'll talk about in much more detail is that your dependencies, a lot of dependencies your stack might have, might not be at the edge with you. And that can actually cause problems, can actually make your application slower. And I'll go through why that is in a couple of minutes. But before that, I just want to give a little highlight to some of the cool things that we're seeing happen in this space around sort of innovative storage solutions. Oh, actually, let me go into this section first. So yeah, why can it be slower? So here is what a traditional sort of backend looks like at the top. The client calls the backend in US East or US West or the International Space Station or wherever these folks are putting their apps to this traditional backend, and that's going to be really close to the database or whatever sort of storage or other dependencies you might have. And typically, there's a lot of interaction going on with that database. You know, one sort of request response on an API might require several calls to a database, calls to other APIs, and so you end up with this sequence of back and forth. If you take that back end and then move it real close to the client, you might actually create a problem where these back and forth, very chatty calls to the database are now taking much longer, because that's based in US East and it's not at the edge. So you can see how, whilst edge might seem like it's going to make your application faster, it can actually make it slower if you don't think about this problem. Does that make sense? Okay. So there's a lot of things you can do about this. We've spent a lot of time at Zuplo optimizing around this problem to get the benefits of edge. And I'll talk a little bit about that. But I want to just highlight some of the other cool solutions that folks are coming up with. So we use Cloudflare workers a lot at Zuplo. That's our sort of default platform that we deploy to. And they've released a piece of technology called durable objects. Has anybody heard of this? Hands up, a few folks. Okay. It's really quite interesting. It's niche in terms of how it can be used, but it's great if your use case requires storage where you store an object. So an object, just imagine, it's just a piece of JSON. And you want consistency in how you read and write to that object, but most of the actors that are reading and writing to that are going to be in a similar locale, roughly a similar area, then it's great for that. And there's not so many actors that a single thread can't manage updating it. So what durable objects does is it creates an object in the locale nearest to the first request that creates it. And then all subsequent requests that read and write for that are going to be ferried around the network to that one location. Now, that might sound wild. If your users are distributed everywhere, this might not be a good solution for you. But actually, so many scenarios, that's just not the case. Think about a chat app, where you're just building a little chat application. Then most of the users tend to be roughly in the same region, same part of the world, in most cases. And also, the number of actors on a given chat, on a single message thread, you'd create an object for each one, is not that many that you're going to sort of break the read-write throughput of a single object. If you meet those constraints, this is a really cool platform. It can really help you write some cool things. So here's how it works. So here we've got a bunch of Cloudflare workers, let's say, distributed around the world. And then an actor A1 comes in and makes a request to this worker here and creates a durable object. So that's going to be located now in that one place forever, and all read-writes will be serialized through a single thread writing to that object. So if a client B1 now makes a request that wants to deal with that object, it's going to be ferried over the network, reading and writing there. But as long as they're roughly co-located, the latency is going to be fine. If A2 comes in and creates a new durable object, that's going to be created in that locale. B1 wants to read durable object 2, it's going to be ferried like this. So there's certain scenarios where this is really, really cool. And I think I just want to show you a quick demo of it, and we're going to use it, again, testing conference Wi-Fi, right now for real. So what I'm going to do is come in here, and we are going to create a Cloudflare worker. So I'm going to make a little demo project for you that's going to be local. We're going to wait a minute whilst we go through all these options. So this is saying, let me zoom in for you. This is saying, do I want the hello world example? Sure. I want to use durable objects. I'll use JavaScript in this case. We'll wait for it to install its dependencies. I don't need to use Git right now. I don't want to deploy the application, and we are done. So I'm going to code this, and let's go open this up in Visual Studio. So here we go, and I will zoom in for you. And here is my source file that's going to be my worker. And I want to save a little bit of time here, so I've put together a little template, but I'll sort of explain this to you, how this works. So you see that there isn't a lot of code in here, right? There is this thing here that represents the sort of the state of the thing we're going to do. And what I'm going to build in real time, and we're going to deploy this really and get you folks to use it, is a little app that will allow us to vote yes or no. I'll have a think of what the question will be in a second, but we're all going to vote yes or no using QR codes, hitting an API, and it will let us see the results. So there's going to be 3 endpoints on this API we're going to build: a yes endpoint, a no endpoint, and a results endpoint, okay? So we're going to be writing this in JavaScript. We're going to be using durable storage. So I'm just going to uncomment these lines of code here. And we're going to write the code for the yes path. It's pretty straightforward. So this.votes.yes++. This.saveVotes will actually save my durable object. And then I need to return a new response, voted yes. Okay, so that's what we're going to do there. And then for the no path, we're going to do something very similar. This.votes.no++. So you can see we're just modifying a piece of JSON, a JavaScript object that will be saved and persisted in the location where the original request came in, and the Cloudflare network will take care of routing to that one object when someone wants to interact with that one object, which I think is really cool. Voted no will be the response, and then if we get the results, what we're going to do here is say, don't you love this? This Copilot thing, it just wrote the code for me. So yeah, that should tell me how many people voted yes and how many people voted no, which is exactly what we want. So I'm going to save that. And then I just need to come in here and set up my durable objects a little bit. So vote counter, these are the bindings to my object. Vote counter, and then vote counter. Save that, and then we should be done. So then I'm just going to say Wrangler deploy, and this one might take a little bit of while on bad network, we'll see. But that should actually deploy the Cloudflare worker for me in real time. We're just going to create a new endpoint now, and then I will get my QR code ready for you once it gives me the URL. Who loves a live demo? Okay, here we go. Copy that. QR.io. Okay, I need a question. Don't scan it yet. Don't scan it yet. Wait, but get your phones ready. So what's the question going to be? I know, okay. How many of you, let's make it really obvious so I get lots of yeses and a few no's. So I'm going to ask a question where it's obvious what you're going to answer, right? How many of you would download random code from the internet and run it on your computer? If your answer is no, then scan that QR code. Okay? How many of you would download random code from the internet and run it on your computer? I kind of know what you're voting. I can see. I didn't think this through, did I? I'll be watching any of you voting twice. Okay, is it working? Did it say voted no? Okay, see, we just deployed that code to 300 locations. That's running here in Stockholm. How crazy is that? Okay, let's do the yes vote. Anyone going to say yes? So if you're thinking yes, vote now. Okay, this guy's voting yes. I love these brave people here. This guy's voting yes. Are you just testing out my code, or are you saying you would download code from the internet and run it on your computer? Just being honest. Not only are you just being honest, it was a trick question. You all do it every day. Anyway, I'll talk a little bit about that and why I just pulled this little nasty trick on you all. Trying to make a fool of my audience is a great way to get good feedback on a presentation, I find. Let me just copy this, and let's go and look at the results. So copy that, come over here, /results. Look at that. So, look at that. We just had durable objects. It was so easy to do that. It's pretty cool, huh? So we got 75 yeses, 75 people. Wait a minute. There's more numbers here than there are people, I think, huh? You guys are cheating. Anyway, so I would definitely say yes. And this is where I want to talk about the security model and the infrastructure behind this technology. So when I say, how many of you would download code, random code from the internet and run it on your computer, and most of you said no, do you not use browsers? Do you all turn off JavaScript? No. You're all running code every day. You download from the internet that you have no view of, and you let it run on your computer. But you do it trusting that one of the strongest isolation models in computing today is browser tab security, right? Think about it. Think about the day zero, and it does happen. Think about the day zero we would have if, sorry, let me go back to my slides here. Think about the day zero we would have if some random dude's web page could talk to a tab that has my bank account details in it on my browser. it's game over, right? It'd be one of the biggest day zeros on the web. And actually, the Arc browser just had something like this, where they accidentally were allowing people to load JavaScript into different tabs via Firebase. I mean, anyway, look it up. It was interesting. But in general, this is the most secure, one of the most secure isolation approaches in computing today. And this is the basis for how all of these edge worker technologies work. It's they're powered by the V8 engine in some cases, or WASM is also very similar. And one of the nice things this allows is us to get to very, very high density compute. When you think about running virtual machines or running containers, you're basically running, in many cases, almost a whole operating system or a very heavy process to support that. That is a ton of waste. A ton of waste being allocated to running this unnecessary stuff just to run a little bit of your code. The browser is one of the most efficient sort of per memory, per CPU ways of running code. And this means that we get massive density when you're running that approach on a server. That's what Dino is about. That's what Cloudflare Work is about. It's what Akamai Edge workers are about. So going more dense is great from a point of view of things like serverless. It allows them to add new processes very quickly when new traffic comes in. Unlike, say, Lambda, where spinning up new processes for Lambdas, quite expensive, and you feel that in the latency it takes to add. It takes these things milliseconds to come to life. It's just like clicking new tab in a browser. So fantastic for so many ways. Also good for the environment, if you care about that too, which you all do here in Europe. I live in Seattle. Not going to say too much about that. OK, so getting leaner, density and lightweightness is the trend. And I actually think that this approach is the future of containerized compute. I think this is the way we're going to go. Like all of these other approaches here, servers, VMs, containers, just stepping stones towards us getting towards a very, very fast, lightweight way of running our code without much waste. So I think it's really interesting to be looking at that. If you want to take a quick picture of this, if you're interested, these are some of the folks who do CDN Edge today. We'll make these slides available as well at the end. So look, a couple of minutes left. Let's talk about some of the best practices. Hopefully you're all excited about edge compute now. It's like, this sounds pretty cool. I should try it out. So let's talk about some of the architecture. I'm going to focus on Cloudflare. Most folks are similar. So we've already said that Cloudflare has about 300 data centers. In each data centers, they will fire up workers that run on multiple machines, but each machine will be running many workers. A worker is effectively what I think of as a process. And thanks to the isolation that we've talked about, they can do that in a very mixed environment very safely. So it's great for building multi-tenant applications. They also have a small amount of memory per worker. So this is not a place where you need a lot of memory. Typically, it's great for things like gateways and so on, or request response. You know, you get about 128 megs per worker, something small like that. But to help deal with all these challenges around distance between the back end, they also provide a bunch of other things like key value storage, which is localized in the data center, a very, very high performance cache, which is localized in the data center, not synchronized. So if I update the cache in one data center, it's not going to be synchronized with another. So there are read-through patterns you do in each one to populate that cache around the world. We do tons of this at Zuplo. It's a lot of our code to get the edge performance we want is solving these challenges. So that's kind of what it looks like in a per data center way. And I've already said that one of the challenges is this long chat cycle that you might have here between your back-end database, which is probably still going to be in one location. There's some really interesting edge databases coming out every day. Now, a lot of people are moving in this direction. This is kind of the future, I think. So what you start to do is use a caching layer. And that caching layer is going to hold that data, any cacheable data at all, you want to be putting into that cache. And now you go to crazy fast read times from your data down to sort of microseconds. Responses internally here with these caching layers. But obviously, in most applications, you can't use a cache for everything, right? Some stuff has to be coming live from the database. And so in that case, what you'll find is you have a mixture. There's some optimization where you have a mixture of some things going back to the database, that one long call, caching, and some things being cached that can. So you have to can make your code maybe a little bit more complicated at first. You start to build patterns around this. You get better at it. You have classes that help you with it. And soon you're off to the races. This is basically what Zuplo does as an API gateway. We've spent a lot of time optimizing this to help people sort of using API management platforms that helps with these problems. So we've got very good at this, so I'm happy to talk about it if anyone's interested. Questions, that's where we've spent a lot of our time. And the way we do that is actually by thinking about many, many layers in our applications. The client comes into the worker where we have our code and your code, which will execute for you. We make smart use of the memory. For the most performance-sensitive things in the gateway, we will actually put that in the memory of the worker. And then we get microsecond read. So it's how we do things like our incredibly fast rate-limiting denial capability. Our incredibly fast API key solution uses this mix. And then we've got the zone caches, which are in the data center. So then we're going a couple of milliseconds instead of microseconds. And then we hit the app server backend database, which is typically owned by you. And that's the solution. So I'm being called on time. So I'm going to say thank you very much. Hope you learned something today and you found that useful. Go check out all the stuff on here, and I'll be around all day, so come say hello. Thanks very much.